Welcome to the third annual Mountain Festival at the University of Alberta in celebration of International Mountain Day. My name is Chrissy Urban, and I'm the Executive Director for the Canadian Mountain Network. International Mountain Day is a United Nations designated day. International Mountain Day came into being in 2002 for the International Year of the Mountain with the United Nations General Assembly. The first International Mountain Day was celebrated in 2003. The purpose of International Mountain Day is to bring focus to sustainable development in mountain regions and eradication of poverty in mountain regions. Prior to 2016, Canada had not participated in International Mountain Day, and then the University of Alberta and the Faculty of Science decided to develop the Canadian Mountain Network with various partners around the country. Our first public event was celebrating International Mountain Day and creating a mountain festival here on campus. Since then, we've had 7 mountain communities and multiple institutions organize various events, engaging over 4,000 people in person and countless online participants around the world. The Canadian Mountain Network is a voluntary alliance of partners from universities, governments, Indigenous communities, and businesses dedicated to the sustainability of mountain environments and communities across the country and around the world. Our aim is for CMN to become a national and global leader in inclusive, co-designed, interdisciplinary mountain research that recognizes the interconnectedness in mountain systems between the environment, the economy, and society, and encourages an integrated approach for long-term sustainability. We have entered the Networks of Centers of Excellence competition in order to gain funding for mountain research and training. The competition's results will be announced in January 2019. I'd like to extend a very warm thank you to the Faculty of Science, to Alberta North, and to the Coast Mountain Culture Magazine for their financial and media support of today's event. I'd now like to pass the mic over to Roger Rapp, the Director of Alberta North, who's kindly agreed to offer acknowledgements and facilitate today's panel addressing the questions of why mountains matter for water. Thank you very much.
Good afternoon. Yes, my name is Roger Rapp. I'm Director of University of Alberta North, and I'll add to the words of welcome, but also begin by acknowledging that we do gather here on Treaty 6 land and on what was also once a Métis river lot, and we do that with a sense of gratitude and memory and obligation to work for good relations in this place and in this country. I'm also here as a friend of the Canadian Mountain Network, have been since its inception, and an advocate within that context for the inclusion of Northerners, and I'm happy that we have Northerners included on this panel today. This is a network in which different modes of knowledge, different locations have come together in alliance, a nice way of putting it. And you'll see that diversity reflected in today's panel. One of the mountain network communities that I always envy is the community of Haines Junction in the Yukon, where they've beaten us to it. They had several days of mountain festival already at the start of December. They have some advantages. They're situated at the base of the Kluane Range of the southeast corner of the base of the Kluanes, and so out their window they have a pretty good view, and you're going to have to do some imagining, but I think we have 5 terrific speakers here who are going to draw you in to the worlds of mountains they know, mountains, water and ice, ecosystems, and sacred significances. Mountains matter for water. I have a feeling you're here because you know mountains matter, but I'm hoping and expecting you will come out of the next hour and a half knowing something you didn't know about why that is. So very pleased to have these 5 speakers. I will introduce them. They will each be at this microphone for 10 minutes. I'll introduce them in turn, and then I'm hoping they'll have a little bit to say to each other, but an important part of this evening will be your chance to engage them as well in response to something you've heard, and so we'll look forward to that. So let me introduce our first speaker this evening, William Snow is here as a member of the Stoney Nakoda Nation, Wesley First Nation, as well as a dual citizen of Canada and the United States. He's of Stoney Nakoda and Yuma Quechan descent. Since 2012, he has been consultation manager for Stoney Nakoda First Nation, work that involves the assessment of industrial resource projects within Stoney Nakoda traditional lands, and that involves him in many consultations with industry, with provincial and federal governments in southern Alberta. In 2016, he assisted in coordinating ceremonies for the Stoney Nakoda Nation for the Bison Reintroduction Program at Banff National Park and Elk Island National Park, as well as the proposed renaming of Tunnel Mountain. And Bill is also known as a member of the steering committee for really for a long time with the Canadian Mountain Network. So Bill, please. My name is
William Snow. I'm the consultation manager for Stoney Nakoda Nation. It's good to be here to see a lot of familiar faces and to be part of this panel. I wanted to say that when I heard about this panel and this presentation, it was I thought it was important to talk about some of the cultural places of water, especially here or down in the Bow Valley. And I really wanted to bring some of this understanding out in the presentation today. So hopefully you may see some places that you know of or that you have heard about, and you'll be able to take away some deeper understanding of those places. So cultural understanding of water places in the Bow Valley. Some of you may have heard a lot of the rhetoric for a lot of different projects over the years. One of the most common themes is that water is life. When we talk about water, we're talking about a life source. We're talking about water as being the blood of Mother Earth. And so when we see water and all of the different uses being derived from it, that part of the understanding, it's more viewed as a resource rather than as a living, breathing entity. For that phrase, water is life, it really tells the story about how water is regarded. And so I think that has to come first. Lakes are not just lakes. Places for water, these are places in the mountains, especially in the mountains, that support our understanding, support our healing, support our rejuvenation, support places for the roles that we play in society. So I'll be covering a few of those places in this presentation. The development of these areas has impacted that cultural use of these water places in the mountains, continue to do so. And so I'm hoping that people will come away with a better appreciation of how we need to protect these important water places in our mountain parks. Stoney Nakoda Nation, we're comprised of 3 bands. We're part of the Sioux Nation. We speak the N dialect of that language, and we are comprised of 3 bands, and we're situated in and around the Morley Reserve down in southern Alberta, as well as 3 other reserves, Bighorn, Eden Valley, and the Rabbit Lake Reserve. One of the more important places for spiritual healing is a place called Cascade Mountain, what we generally term as Minerva. This is a place where Stonies would come to and camp at the foot of this mountain in order to take advantage of the spring waters that would come off of this mountain year-round. So this is a very important spiritual place. If any of you have the chance to go over and visit the Royal Alberta Museum, you'll be able to see a display of this mountain as one of the 10 spiritual places in Alberta. I was able to sit on the terms of reference group for the new museum, and so that particular place is captured within the exhibitions at the new museum. So a very important place, Minerva, and it's always been regarded that way. We still do a lot of our events within Banff National Park, and it's still a very important place for the Stoney people. Right adjoining it, another display at the Royal Alberta Museum is Lake Minnewaca. Also an important cultural, spiritual place, but for rejuvenation. Our stories talk about how people of our band were sacrificed in order to have the tribe survive. And so these are very important places. Minnewaca, Mini being water, Waka being God, and the combination of that in this instance is the Lake of the Spirits, as it is translated as. So these are places that are important, not only just as water resources for processes like reservoirs and dams. These are places that have stories attached to them, and those stories we still remember and we still take that meaning from them, and that's why we regard them as very important, very sacred. Also, there are places for physical healing. We talk about places, Yarhe Achberbin, mountain with the hot water, from where hot water comes from. Hot springs were used much like they are today. A lot of tourism and commercial developments for people going up to use the hot springs. This was also used for spiritual purposes. So people would go in and do ceremonies before they would go in and use these places for their spiritual healing. Very important places used traditionally and are still viewed that way. Minerpa, Yarhe Achberbin, Lake Minnewaca. These are places that are have always been important for the Stoney Nakoda people because of the water properties of that particular area. So very important that these places be protected. Outside of the Banff area, if any of you get a chance to go up and visit or know of the place up in the Upper Kananaskis, very important water sources there as well. Ozada Yimne, the upper lakes of the Kananaskis River. A lot of reservoir and dam developments have happened there over the years. But these places are important because these are where our people would go and have solitude, would meditate, would understand their role within our society, within our groups. When those are affected by commercial developments or affected by hydro developments, then it changes the nature of that place. These are the places, though, that would be used for understanding what our roles were in our societies. So it's really important to not only look at these water resources just as reservoirs and as a resource to be used or taken advantage of or to be charged out to everyone, but there is inherent quality within these places that teaches us and tells us who we are. I just wanted to end off the presentation here by talking a little bit about one of the quotes from my late father's book. My people say if you destroy nature and the environment, you're destroying yourself. But if you protect the environment, safeguard the water, ultimately you are protecting yourself. So that's the kind of perspective that we need in our decision making in how we protect and promote places, is to understand that not just the financial quality of a place, but the cultural value of a place and why that's important, why that has been important historically, and why that's still important today. Thank you. Mishnish.
Thanks, Bill, for getting us off to a great start in answer to the question, why do mountains matter? Bill Donohue is visiting scientist at the University of Alberta, but he is also the Executive Director of Science in Alberta Environment and Parks Environmental Monitoring and Science Division. He earned his PhD in aquatic science from the University of Alberta. He then completed a law degree, which is there must not be many of your kind. Has worked as a private consultant, worked with an NGO and since 2015, I think, with the Alberta government. His research interests include the interactions between climate change, human disturbance, ecosystem function, especially around water, and carbon and contaminant dynamics, and also the use of market-based instruments in policy to incent sustainable environmental decisions and management actions. Please welcome Bill Donohue.
Thank you, Roger, and thank you, Christy and Kathy, for putting this all together. I'm going to talk mainly about climate change and its impacts in the mountain regions of Alberta in terms of its effects on water quantity and quality. My understanding is Rolf will be talking a little more about sort of what follows after that. But I'm going to introduce you to sort of where we've come in terms of climate and then what's anticipated. And the mountains in Alberta are particularly important. There's the notion of sort of mountains as water towers. In Alberta, we live in the rain shadow of the Rockies, and all of our major rivers that start in Alberta originate in the foothills or in the mountain regions. And we're heavily reliant on these rivers that begin in the mountains. And well, climate change, as what I consider to be primarily a physical driver, is going to play out in terms of its effects largely in terms of sort of introducing changes in the balance between precipitation and temperature. When you think about it in mountains, it's a case of, the temperature determines what form the precipitation comes in. Is it rain that runs off, or is it snow that can be stored seasonally or perhaps longer term in snowpacks and ice? And so as we go forward, we're looking at change. Historically, mountains in west central Alberta received a lot more water precipitation than the rest of the province. I'd say from this map you can see, in the mountainous regions we were getting 650 or more millimeters per year. Down in the Palliser Triangle, 300 millimeters or less. Interestingly, and what most people don't realize, the far north that's typified by these vast boreal wetland complexes actually had similar precipitation to substantial parts of south and eastern Alberta. But of course the difference is, for a variety of reasons, but substantially, it's cooler up north, it's a lot warmer and windier down south, and so that difference in terms of water supply may have substantially to do a lot with evaporation and evapotranspiration. If you look at the changes in water, this is a summary of the changes in precipitation over the last 70 years in Alberta. The areas I've circled are where there are significant changes. In the mountains, on a decadal average, every 10 years, we've seen an average increase of 30 millimeters or more per year in precipitation. So basically 30 times 7, we're talking 200 to 250 millimeters more of rain each year now than 70 years ago. Up in the north, Caribou Mountains region, about 10 millimeters per decade, so 70 millimeters or so in the last 70 years, more today than 70 years ago. And then in the south, a decline of about that amount, so 10 millimeters per year less for each decade. So about 70 millimeters less now than 70 years ago in south central Alberta. And so you think, well, the mountains, we're getting a lot more rain, that's great. It's important to note, though, that the precipitation, there have been seasonal changes as well. These are the data from December, January, and February. What's shown generally where there's green, it means there's been a substantially less precipitation falling in the winter. Substantially, the southwestern half of Alberta is basically showing significant declines in winter precipitation. In the mountains and foothills, 15 to 20 millimeters per decade over the last 70 years less precipitation as snow. And so what that means is, if we're seeing more precipitation in the mountains but less as snow in the winter, then it's likely coming more as rain, and there's a shift seasonally. In terms of temperature, where it's red, that basically it shows that there's a high increase in annual temperatures over the last 70 years, greater than 0.4 degrees per decade. So if you think about the descriptions and projections for climate change globally, everyone talks about 1.5 to 2 degrees is sort of these critical thresholds. It's important to keep in mind at high latitudes like where we are, It's actually a lot more than that. That 1.5 or 2 degrees is a global average. And as you head towards the poles, you're looking at much higher projections. So in the last 70 years in North and Central Alberta, we're looking at already having experienced of around 3 degrees centigrade increase. In the mountains, it's about half that. So 1 to 1.5 degrees centigrade already in the last 70 years. And similar to precipitation, a lot of the changes are occurring in the winter. So about twice the warming rate for December, January, February as seen on the average for the annual. So in the north, we're looking at almost a degree of warming per decade over the last 70 years. In the foothills, 0.2 to 0.4 degrees centigrade. Pretty substantial changes, and again, you combine that with the precipitation and the shifts in terms of what comes down as snow or rain. It has pretty substantial impacts on patterns of water supply in the mountains. One of the consequences of this, we've seen glaciers declining. This isn't just around here, it's pretty much observed globally. But historically, glacial melt in the summer comprised up to half of flows in the Bow River at Banff. Most of the headwater glaciers in the Bow, Saskatchewan, and Athabasca rivers have shrunk by 25% in the last century. In the Bow, the extent of 21 glaciers in the Hector Lake Basin declined by about a quarter in terms of their area. And that's just in the last 50 years of the 20th century. Ultimately, because the size of the glaciers is withering away so dramatically, while increased melting results often in an increase in meltwater flows, in some cases they're looking at declining flow, notwithstanding that the rates of melting are increasing just because the mass of ice has kind of reached that tipping point in some of the glaciers. Just a couple of examples. I imagine many of you have been up to the site at the Athabasca Glacier where you can walk around at the visitor center and they see the decadal or sort of multi-year signposts that mark the toe of the glacier over the years, and you can see how it's receded substantially over the last century. Similar to the Bow Glacier, it's receded over the last 100 years up the valley and over the cliff. What that means is there's going to be substantial changes in the amount of water. There may be increases in flows in some of those glacial rivers, but at some point they may reach these tipping points, and then we'll see what happens. I'm going to talk a little bit about the Athabasca River. It's the only major river in Alberta that's not affected by dams, and so it's useful for looking at long-term changes in flow. Each of these sites is where there's a main stem monitoring site for river flow. The Swanwapta River flows off the Athabasca Glacier, and then between Jasper and the glacier, it joins with the Athabasca River. So if you look at total summer flow May to August between 1970 and recently, so the last 40, 50 years, the Swanwapta River has actually demonstrated about a 20% increase in summer flows, total summer flow. However, if you go downstream to Jasper and Hinton, there's no real change. The variability year to year swamps any real trend. But as you go into the lower reaches, the lower almost 90% of the watershed, the further down you go, the greater the long-term change in the flow decline. So there's kind of this almost a teeter-totter. In the headwaters, you see an increase in flow. In the lowlands, you see a decline in flow. Now, if you look at the amount of the watershed that's between the sites, so basically at a downstream site, you subtract the flow from the upstream site, and then that's essentially the net change in the water in the river. And if you divide that by the area of that watershed between those two sites, you get effectively a measure of the, call it net runoff, so the amount of water being delivered from the watershed into the main stem river. Again, upstream of the Swanwapta River, it's been increasing. There's increased melt and flow, and so 21% increase. Similarly, Jasper Hinton, there's no substantial change, but if you go and look downstream of Hinton, you see an increasing decline in the amount of water coming off the watershed. So what this suggests is, or what it clearly demonstrates, I'd say, is you're having more water getting into the river in the headwaters and less water coming off the watershed in the lowlands, and that's the lower 93% of the watershed. So I guess you could argue that only in the headwaters is there an increase, and everywhere else it's declining. Now, the notion of mountains as water towers. Over this period, what it means is the flow in Jasper, in 1970 it comprised 15% of the total flow in Fort McMurray, but more recently it's up to 23%. So it's increased its proportion of flow to Fort McMurray by about 50%. And so it's becoming increasingly important, I would say, for further downstream in terms of the amount of water that's there. The Sunwapta, obviously, it's glaciated, it's very rocky, you have very flashy flow. If it rains, it's going to end up in the river very quickly. If it's a warm summer and melting, you get a lot more melt water. This is just a history of flow in the Sunwapta over the period of record, so from 1948. It's pretty variable, but it's a long-term general increase, and it's up by 40%. What we see is heavy snowmelt and summer glacial melt delivers high sediment loads into the rivers. This is a picture from the other side of the Continental Divide on central BC. You get a lot of sediment loads into streams, lakes, and rivers, very flashy flow patterns at high elevations. Typically, these systems have low nutrients and low organic matter because of relatively low organic soil in the catchments. There was a picture initially in all of the kind of the slides going around of Moraine Lake. I don't know, I imagine some of you have been to Moraine Lake. This is the valley above it, Valley of the 10 Peaks, and the glacial moraine from which the lake gets its name. So, of course, this is substantially the supply for the Moraine Lake. The pale blue color of many of these lakes in the mountain regions is a result of glacial flour that comes out of the glaciers, ground up stone. Glaciers also are long-term repositories for a lot of global pollutants, more volatile organic contaminants, different pesticides and herbicides. They kind of end up in the atmosphere and they precipitate, come down. In many cases, been stored in glaciers over the last century. With increased melting, of course, we're getting more delivery of a lot of these pollutants, either from dust or just sort of precipitation of these organics getting into some of these headwater systems. And of course, as these glaciers melt more, we can see more of these things delivered into the aquatic systems and food webs downstream. So where are we going? As I said earlier, projections for climate change for this part of the world are much more than 1.5, 2 degrees. For the Saskatchewan and Alberta, generally, we're looking at projections of about 6.5 degrees by the end of this century, warming. To put that in context, that basically means that the climate in Fort Smith in the Northwest Territories switches to the climate in terms of temperature of Calgary. Pretty substantial changes. During the last century, I don't know if many of you are familiar with the Mountain Legacy Project, but they've gone back and taken photos of various views in the mountains that were photographed long ago. So this is Bull Creek looking west into the Highwood Range and the changes over the 20th century. So you can see tree lines go higher. With that comes a lot of soil development, and of course there's been changing climate at the same time. So what happens with climate change, we'll see more melting, potentially higher runoff in the near term, but perhaps also eventually declines in flow. As the tree line moves higher and runoff dynamics change, the water chemistry in these systems will also change. There's more organic inputs from soils, longer ice-free seasons, warmer temperatures, perhaps more light. Fire frequency and severity is something we can't forget also. With climate change, we've seen fewer beetle kills and in the winter, and therefore a lot more pine beetle kills of trees. This year was a perfect example of what can happen in a bad fire season. It can result in changes in the dynamics of nutrients, various metals, natural and anthropogenic organic contaminants end up getting into these systems, and fire and all of these other things can interact in ways that result in significant and somewhat surprising, in some cases, food web dynamic changes. So I'd say the watchword is just we're looking at a lot of change. And so I guess what we expect is the mountains won't be, I think, what they have been in terms of how they function and how they look. And so
Thank you. Rolf Weinbrook is Professor of Biological Sciences at the university. He's an aquatic community ecologist focused on the cumulative impacts of multiple stressors, climate change, eutrophication, invasive species, and so on, from alpine to prairie lakes and streams. He's part of some significant international research collaborations. He's a biodiversity theme leader for a proposed NSERC strategic network called Alpine Freshwater Futures, and he sits on the board of the Alberta Lakes Management Society. So happy to have you here as part of the panel.
I'm going to see if I can kind of give a highlight reel here as to some of the ways in which some of the environmental changes that Bill kind of just did an overview of can actually affect the ecology of a lot of these systems. For those of you that are familiar with this, I pardon myself, but like a lot of people actually kind of think that a lot of these alpine systems, like shown here in the northeast corner of Banff National Park, are relatively pristine, untouched systems. And what I'm going to try and show to you tonight is that's probably a fallacy in many cases, and they are actually experiencing a number of different types of environmental changes that are either novel and or extreme, and they're generally a result of human activities, and that's why we call them stressors. The ones I'm going to talk about tonight are, I'm going to go in a chronological order. You may or may not be aware of the extent of exotic sport fish throughout most of the National Mountain Park lakes that we have. Compounding that is, like Bill was talking about, is more recently increases in higher temperatures, and also associated with that in precipitation patterns, the melting of glaciers. I'll show you how that's actually changing a lot of these lake ecosystems. And then finally, something that I think everyone can relate to from these past couple of summers with lots of forest fires is that there is also an increasing potential impact of increases in nutrient deposition falling on these relatively unproductive nutrient-poor lakes as a result of forest fires, and also nitrogen deposition from emissions from combustion engines. So it'd be a very, very simple talk if I just went through each one of these and said, you know, we know the impact of this, we know the impact of that one. If we just added up the known impacts of each of these individual ones, we could be pretty confident in predicting or forecasting how these lake ecosystems should respond to all of these. But the real challenge here is, like I'm going to show you in a few cases, is that in many instances, the effect of one of these environmental changes or stressors is mediated by another change, such that the net effect of the two together or more of them together is not equal simply to the sum of their individual parts. And that's where the real challenge lies, is scientifically and also in many other respects as well. So I'm going to try and show you how these interactions really sometimes run the system. So a lot of the lakes that we actually work on are shown here in terms of like data that we have for water chemistry and biological factors. So a lot of things I'm going to be showing you tonight is from this sort of subset of almost over 400 lakes and ponds throughout the Canadian Rockies. So I'm going to start historically. So we go back several decades to post-World War II, perhaps even a little bit earlier than that. And if you were in the National Parks area, you would have seen a lot of these sorts of things. First of all, park wardens carrying around small little fingerlings of different types of trout species in their backpacks, and then dumping them into lakes that seem to be judged to be kind of like lacking in recreational appeal. So if you throw fish into them, you'll bring more anglers into the park system and you'll get more tourism revenue. So that was the first kind of motivation behind this. That horse pack kind of got replaced by this helicopter drop that you see right here. And then if the lake was large enough, often you'd have a bush plane just kind of come and dive bomb it and throw numerous small little fish. If a few of them survived the crash, they would successfully reproduce, and you'd have fish where there were no fish before, and you'd have more angling dollars. That happened, and this diagram showed right here for several decades, kind of reached a peak in the 60s and early 70s, and it kind of tailed off towards the 80s, because if you might be aware of this, but UNESCO declared the National Mountain Parks in Canada to be World Heritage Sites, so it's not a very good thing to be throwing in exotic sport fish from different parts of North America and also from Europe into these systems. So that was basically terminated towards the 80s, but not before, like I said, a lot of these lakes became established by self-reproducing populations of exotic sport fish, to the point where you started getting still these very strong efforts by the parks and recreational outfitters to attract people to the National Mountain Parks by way of something like this. The very well early pre-Photoshop doctored photograph showing you the monster fish that you could possibly catch if you came to the National Mountain Parks. If anybody knows anything about fish, you can kind of see there's no such thing as a trout that's as large as a horse, but very well done. A lot of these lakes still have fish, just not quite this large. The interesting thing is that we've shown repeatedly in various different types of studies, surveys, experiments, that if you have a large introduced fish population into some of these relatively small mountain lakes where there were no fish before, the fish themselves increase the amount of nutrient cycling that occurs within the lakes, and they actually fertilize the lakes such as to increase plant and algal growth. Now you might say, well, maybe that's not that bad. The point here, like you'll see in a little while, is that if you actually increase the amount of algal growth in some of these relatively unproductive lakes, you are kind of playing a little bit with danger because you could be encouraging outgrowths of nuisance and unwanted algal material. The other thing that you can kind of see here is that on top of this effect, just like in the previous slide as well, is if you also increase experimentally these systems with higher temperatures, there's kind of a synergistic effect between the fish fertilizing effect and also warmer temperatures, such that you get an increase in not only algal growth, but you also get an increase in the amount of plankton within the lakes. And again, a fisherman who knows that lots of trout eat plankton, they'll say, well, that's not a bad move. That'll just mean that the fish will even do better and there'll be more for me to catch. The problem is here that the increase in plankton production is primarily attributable to small little species of plankton that the fish themselves cannot actually visually detect. So those are really kind of go exploited by way of the fish. So they don't really result in having an increase in food availability at all. But you have an increase in lake production. So I'm going to move on to some of the other impacts. Going back to it's perhaps a little bit more recently, there's a number of different models, like this one shown here from 2004, that showed that at higher elevations, particularly at the mid-latitudes in North America, and we're kind of somewhere just showing that there's an epicenter of increased warming at higher elevations just around the 40th to 50th parallel, somewhere, like in Montana, but we're in that kind of zone as well. So with these increased warmer temperatures, and like Bill was mentioning, also changes in winter precipitation patterns, you get things like glacial recession. So here's one of many, many examples that show that the footprint of a glacier from 1985 to 2003, when I took this photograph, had substantially receded. And this is an example of all around, like Bill said, around the world, and particularly pronounced here. The interesting thing is that you wonder how much this actually influences lake ecosystems that are at the base or receiving these glacial meltwaters. So if you go back to some archival photograph to 1949, and you'll see the Mount Fritzl Glacier right here in the foreground, and you'll see a number of lower valley lakes that would routinely receive turbid meltwaters from these glaciers on an annual basis, causing them to be chalky, milky white, like the ones shown right here, the one in the red bullseye, whereas the ones that weren't in receipt of glacial meltwaters, like the one on the far right, remained relatively dark and clear. But with the disappearance or recession of some of these glaciers and the reduction amount of meltwater, you actually started seeing these lakes become progressively clearer and clearer. And the example here is on the far right, you see a sediment core that we obtained from this lake that shows that for quite a long period of time, the amount of sediment that was accumulating at the bottom of the lake was this kind of like dark clastic clay or light clastic clay material. And then just recently at the very top, you see this very, very faint, more darker organic material reflective of the fact that these lakes are no longer receiving as much rock flour. That's not as pronounced an impact as this next slide, where you can see that it's not an isolated case, but these are a set of a half a dozen cores from various lakes that we had cored. And we had thought we were going to these lakes and not going to be seeing any sort of glacial influence because there were no glaciers any longer present. But almost in all of these cases, you can kind of see that somewhere down the depth of each one of these cores, you see a very marked transition between the deposition of very light clay materials, suddenly then followed by more recent deposition of darker organic rich material. So a lot of these lakes are becoming progressively clearer. And as a result, light penetration gets to a deeper point within these lakes. And as this sediment core here shows from McConnell Lake, which is in the above the Clearwater area in the northeast corner of Banff National Park, with that transition from the clays to that dark organic layer, the amount of chlorophyll that's being deposited in the sediments, in the darker sediments at the top, which is reflective of the amount of algal growth that's actually occurring within these lakes, actually goes substantially up. I would even say to a certain point almost exponentially. And the other dashed line that you see there that's showing the reverse is just to show you that this is not an artifact due to degradation of the chlorophyll as it gets more and more buried. It's a real impact. On top of that, we're getting clearer lakes stocked with fish, more and more nutrients, more and more light. What else could happen? The last one I'm going to show you here is something to do with nitrogen or nutrient deposition. Nitrogen deposition is a really strong concern, more so above our American partners than us. But like this paper shows right here, southern parts of Canada are showing evidence of elevated nitrogen deposition as well. On top of that, like I mentioned at the start of my talk, you start seeing an increased frequency in the amount of forest fires in the national or in the Canadian Rockies. As a result, you see a lot of ash being thrown up into the upper atmosphere. That ash is typically relatively rich in phosphorus, which is also a very important limiting nutrient to lake ecosystems. So you're getting elevated nitrogen, elevated phosphorus as a result of fires. And if you look at this slide and you go, wow, if you add nitrogen in the middle panel and you add phosphorus in the middle panel and you add them together, which is the giant purple bar right in the middle, they actually amplify each other's fertilizing effect on algal growth within freshwater systems. So if you have both of these occurring at the same time, you can expect a greater impact than is the sum of their individual parts. This is just an example here that what we often use is a dissolved inorganic nitrogen to total phosphorus ratio on the y-axis. It shows that that ratio, which is used to infer what kind of nutrient is limiting a lake's productivity, varies or depends upon the maximum depth of the lake. If you look to the far left, the smaller lakes that are below 10 meters in depth typically tend to have very low ratios, which suggests from chemical inference that they are very, very sensitive to nitrogen, and some of them might actually be co-limited and get those synergistic effects from phosphorus and nitrogen. But this is just chemical influence. So we got a permission to use a set of Alpine Ponds, and we did a cross-factorial experiment of nitrogen and phosphorus fertilization to see if this was in fact the case. And as you can see here, pay attention for this very short talk. On the right-hand slide, where you actually see that the impact of phosphorus alone is not that substantial, but when it's coupled with the addition of also nitrogen, simulating nitrogen deposition, you get, again, an increase in amount of chlorophyll or algal growth within these systems. Take-home message is that all of the different stressors that I just showed you essentially can all, in an interactive fashion, increase the productivity of these alpine systems to the extent where in the future, we might actually start seeing decreases in water quality that are associated with increases in algal growth, something that we see much more so at lower elevations here in southern and central Alberta. But there are already some reports that you are starting to see these harmful or else at least nuisance algal growth occurring at higher elevations. So that's something just to look forward to. Not really. Thanks.
Thank you. Dan Farr is Director of Biodiversity and Ecosystem Health Sciences with Alberta Environment and Parks. It says here, and some of you would have seen this online, that his childhood interest in animals led him to study bats at the University of Manitoba, garter snakes at the University of Victoria, and songbirds at the University of Alberta. And that armed with all this education, he landed a biologist job at Hinton with the Foothills Research Institute, where he realized how little he knew. So I think what we will get today is the wisdom gained over some experience working in different sectors in the province. And Dan.
Thank you, and it's a pleasure to be here. Thanks to the organizers for hosting. I think either I didn't get the memo that this is about water, or you didn't get the memo that I'm not an expert on water. But the place that I'll be talking to you about is indeed the water tower for the Prairie Provinces. And I guess in my presentation, I'm going to talk to you about some of the other things that are going on, other land uses that are occurring in this area, and how we might consider them to be living laboratories to learn how to better manage them. Start off with a brief historical context, talk to you about some of the ways in which we try to manage human activities in our headwater ecosystems, remind you that much of the impacts of human activities is uncertain, and just briefly introduce to you the idea that we can think of these ecosystems as living laboratories. A reminder that Indigenous peoples have been here for time immemorial. They are the original stewards of this land, and that this land has material and spiritual and other value for all people, and that there's a ton of knowledge in the Indigenous communities, people in Indigenous communities, much of which hasn't been reflected in the way we understand and manage these ecosystems. In 1896, a surveyor from the Federal Department of Interior wrote a report about the eastern slopes of Alberta. And he wrote that the permanency of our water supply is largely dependent upon the preservation of the forests at present covering the watershed, and this protection can only be secured by prohibiting the cutting of timber. He and others at the time understood that these areas were water towers and that the development of agriculture and settlement in the prairie provinces depended on that. And the removal of forest cover was seen as a threat. And so in 1896, the position of the federal government was, well, we need to make sure that these forests aren't cut down. Well, somebody figured out that, well, actually, we do want to cut them down because there's wood resources in these ecosystems as well. Around 1906 and onward, through legislation like the Dominion Forest Reserves Act, we got notes like this: to protect the resource for the purpose of maintaining a continuous supply of timber, to benefit water supply, and protect the animals, fish, and birds within the reserves. So there's 3 different types of values reflected here: the production of timber, the protection of water, and wildlife and fish. And then lastly, fast forward to 1984, the last major revision to policy, and this is a provincial policy now in the Eastern Slopes. It's called the Eastern Slopes Policy. And it acknowledged or recognized and tried to support 3 types of values: watershed management, recreation and tourism, and natural resources, primarily wood resources, coal resources, oil and gas. A range of tools, management tools, were identified and laid out in this policy, but the main one was zoning. Areas at higher elevations were considered and labeled to be prime protection, where industrial development was permitted. And then on the lower slopes and the foothills, industrial production and other values were all permitted for. So since 1984, the Eastern Slopes Policy, the Eastern Slopes have continued to change. We see more footprint, more land use. And through a changing demographic, we also see a diverse range of values. We are becoming and have become an increasingly urban population in Alberta. And I would argue, and others have argued, that the range of values that we expect from our headwaters ecosystems is broader now than ever. Top right is simply a media report suggesting that some Alberta ecosystems, and this one is from the foothills east of Edson, or west of Edson, are shrinking faster than the Amazon. True or false? Fake news or not? Anyway, and that's just an image from the area east of Edson, as I say. Okay, so what are the management tools that are used in the headwaters areas to sustain the kinds of values that I've talked about? There's a wide range of them. I'm listing 5 of them here. Conservation areas, the regulation of linear disturbances and their use by people, especially people on motorized vehicles, forest harvesting, prescribed burns and the manner in which we respond to unplanned fires, wildfires, and post-wildfire harvest and silviculture treatments, which is a long way of saying salvage logging. When unplanned fires do occur and they're in an area where logging has been planned, we often get in there and take the merchantable timber out before it rots. I'm also going to talk to you about 3 different areas where evolving land use regulations have occurred. Starting at the bottom, in the Castle area a couple of years ago, public lands were altered in their designation to primarily 2 big wilderness parks and a provincial park. Livingston Porcupine Hills is an area north of the castle where concerns over overuse by off-highway vehicles led to the development of new regulations limiting the amount of use by off-highway vehicles. And then the upper North Saskatchewan and upper Red Deer River basins, which collectively intersect with an area called the Bighorn area, is currently on the table for modified land use designation to increase the degree of protection in at least part of that area. So going clockwise, starting with conservation areas, these are those management strategies or management regulations. So along the green, high elevations, we've got the big national parks, Banff and Jasper. In the darker green, we've got 2 provincial wilderness areas. Within what we call the Bighorn backcountry, these are currently public land use zones or PLUSs, where we limit the industrial activity, but we also limit the ability of people to be in the area on trails. Especially in the David Thompson corridor, close to Saskatchewan Crossing, and other areas too, but we use prescribed burns. We use it to reduce the threat of wildfire, and we also use it to increase habitat for wildlife that prefer early cereal stage forest. Forest harvesting, I'll show you a map of where this occurs. It's essentially a management strategy to produce timber, but also produce wildlife habitat and other values as well. Wildfire suppression occurs throughout. We've got a long, proud history in Alberta and elsewhere in Western Canada of suppressing wildfires. It's been more or less successful. There are fewer burned areas in this part of the eastern slopes likely than there would have been had we not put them out. And then lastly, I mentioned salvage logging. There has not been a lot of fire in this part of the eastern slopes, but when it does occur and it's eligible it's in a place where it's eligible for logging, we do some salvage logging. So these are some of the management actions that we use to sustain the sorts of values that we're interested in these headwaters areas. And so how have we done? What's been the result over the last several decades? So I mentioned, as you may be aware, conservation areas, which in the white areas on the west side are the national parks and provincial wilderness areas. The gray area there is what's known as the Bighorn backcountry. It's an area that is currently public land use zones, which is currently being considered for modified designation. So what that's done is it's avoided the development of roads, which are a signal of industrial development in the areas we call west of the Trunk Road. Trunk Road is that red road that goes from the north to the south. And so the roading that has occurred in this part of the eastern slopes is primarily east of that to support forestry activities, oil and gas activities, and close to the prairie grassland areas, agricultural lands as well. Secondly, as I mentioned, wildfire suppression has altered the fire regimes throughout the area. It's altered them in the mountains and it's altered them in the foothills. So in green here are all the areas that have burned since 1961 in the Bighorn area. It's less than 1% per year, which is believed to be far below the historical rate of burning, which in some of these areas would have been far greater than 1% per year. Fire regimes are complicated. It's not just the area that's burned, it's how hot the fires are, what season they burn in, and many of these other parameters of a fire regime have also been altered. And fire suppression is a main driver of that altered fire regime. But it's also important to remember that historically, Indigenous peoples that lived in this area also conducted traditional burns in low elevations to support wildlife habitat, but also in higher elevations and elsewhere for other purposes as well. The resettlement of Indigenous peoples in the late 1800s caused an ending to that traditional burning, and that has contributed to a reduction in fire as well. In the foothills, which are the areas east of that trunk road, north-south road, logging has quote-unquote replaced fire. And I use quotations because, of course, logging and fire are not the same, but they do have some similarities. Severe fires and clear-cut logging both remove most of the living trees in a block or in a burned area, but there's also lots of differences as well. In burned areas, anyway, I won't even go into it, but I'm sure you're aware there's lots of differences between logging and fire. So replaced is something that you need to think about in quotations. I mentioned roads are limited in this area to the areas east of that forestry trunk road. And the result is that road densities in the areas that are protected, that is the green part of that bar, and the areas in the Bighorn backcountry, which are largely protected, that's the black, have very low road densities. The red dashed line indicates the density of 0.6 kilometers per square kilometer, which is often used as a management threshold. And there's some biological basis for this. In areas where road density exceeds that density of 0.6 kilometers per square kilometer, evidence suggests that grizzly bears may not be able to sustain their populations. There's a long explanation for that, but that's a common management threshold. But of course, in addition to roads, there's other types of linear disturbances in the eastern slopes as well. Seismic lines used to explore underground reserves of oil and gas are a big one, but also pipelines and other linear developments. So when you add all that up, you've got a large area where there's quite a high density of linear disturbances. We don't have a management threshold developed for any linear disturbances except for roads. So we're really uncertain as to what the kind of impacts this footprint will have. So in summary, some of the main stressors that are active in this part of the eastern slopes are altered fire regime, linear disturbances, forest harvesting, and climate change. One of the reasons we're uncertain about this is that we haven't studied these ecosystems very much. And this will be my last slide. It's what we call a systematic map. It's where we went to the library and we entered keywords. It's not in Google, but it's a web of science. It's a similar kind of process that you would use when you're searching. And in each of the searches, we combined a species, and the species are grizzly bears, bull trout, moose, bighorn sheep, bison, and a couple of species of pine trees. So we combined each of those species with a stressor. And there's 4 categories of stressors that I'm showing here. Altered disturbance regime, bracket fire. So essentially we're looking for research studies of the effects of an altered fire regime on each of these species. Altered disturbance regime, bracket forestry. So these are studies of the effects of forestry on these species. Linear disturbances, so studies of how linear disturbances might affect these species. And other stressors like contaminants, altered hydrological flows through dams. The result is that if you're a grizzly bear, you've been really well studied compared to almost every other species. Grizzly bears attract research funding. They attract social attention. And that's partly why we've seen in the last few decades so many more studies of how grizzly bears respond to these stressors as compared to almost any other species. So the part I'm not going to get so much get to, and I'll maybe speak to it if there's time during the panel discussion. There's so little evidence to support evidence-based decisions that I think it's important that we do think about these headwater ecosystems as laboratories where we are changing the way we manage them. And if we can couple those changes with research studies, including studies led by citizens, then we can accelerate the learning and make even better decisions. Thanks very much.
Thank you. Our last speaker of the evening will take us out of the Rocky Mountains and up to the Mackenzie Mountains, and a mountain range less familiar, I suspect, to most of us in the room. Leon Andrew is Shitagotene Elder, the Toledo Dene Band. He is on the Satu Renewable Resources Board. He holds a position on the board of the Toledo Land and Financial Corporation, all of this in the NWT. He has been an advisor to a lot of processes, the NWT Water Stewardship Strategy, the Transboundary Water Negotiations in Western Canada, the Canal Heritage Trail Committee for the Toledo District. I know he has advised Government of Northwest Territories archaeologists from the Prince of Wales Museum. And on top of that, he has been an active trapper in the Toledo area and has firsthand experience of the positive and negative effects of resource exploration in his part of the world. So Leon, please, glad you're here.
Thank you, everybody. Thank you for inviting me. Yeah, it's true that I live in the central Mackenzie Mountain. Our culture in respect to water, we respect water a lot, very much. It's very important. We practice by taking water, we give something back to the land, or water. We do the same with the land. We take something from the land, we take it back. put something back. Our elders are very strict on that. Water is sacred to them, and I liked what they said about mountain matter for water. It's true. The backbone of the mountain, Mackenzie Mountain, is right border right at the Yukon and NWT, and we have both water flowing both ways. The headwater, this is Keel River. I want to talk a little bit about Keel. It comes out in Mackenzie River, just about 70 miles south of Toledo, Norman Wells. And the Hanny River, it's all in the central area. The Hanny River flows, Keel River flows, Redstone River flow, Caribou Cry, Twitchy River, all the river system flow all direction, almost like four ways to supply the north. Why I'm showing this piece of ice is to let you know that I've been out there with an archaeologist back in 2007, and those ice were there at the time. And on that piece of ice there, we found a ground squirrel snare, which was dated 1,000 years. So we know that that ice has been sitting there for 1,000 years. But 2007, 2017, 10 years, just a little piece left. Just a little piece left. So there's a big change, like my colleagues are talking. I hear what they say. One of the things what I noticed through my lifetime, it was the effect of the wind. The wind came up through the west on the mountain. It just blew and blew for 10 years. And it melted everything in its way. That's what I experienced. And the other thing I want to touch on is the river system itself, or the ice path rather. The ice provides water for us and all living things that we live with. That means we have lots of doll sheep, caribou, moose, and abundant fish on the river. That's what we live by. We hunt and live on those supplies. And the way the weather is going, I don't know what's going to happen there. If the glacier melt, then what? Where do we get our supply of water? I always imagine that. So it's very important for people that came out here to listen that there is something real happening out there. Mackenzie River, during that period of time, I was talking about 2007, 2012. It was very low, and you couldn't get the barges in and out of the community to get supplies. It was pretty bad. But that's the way it is. What can you do about it? I think one of the colleagues says that maybe more research should be done within Mackenzie Mountain about the ice, the glacier, how fast it's melting or how long it's going to be there. That'd be very, very interesting to find out. And the caribou too, they rely on those ice. They lay on those ice when it's warm. Those are about 6,000 to 7,000 feet, by the way. And I show this picture because that's where our people go to hunt. They get their food from there. It has everything you need. It's just like a warehouse. You go there, you get your supply for the winter. I don't know if I want to carry on about Mackenzie Mountain, but I just want to stress out the importance of water. I do some work with for the land corporation, my land corporation in Satu region. And then I do a lot of water strategy for them with the government of Northwest Territory. And they have the same concern too. All my colleagues up and down Mackenzie River, the north and to the south. The water becoming an issue for us. So I want to leave it at that. If you want to talk to me later, it'd be great. So thank you very much for letting me speak to you for a bit. I really appreciate it, and thank you both. Merci.
So we've got some time. If we'd had a little more time, I would have said the first exercise is to have our panelists imagine one thing that they wanted to say to the person next to them or a question they wanted to ask. But I think in the interests of time, I know you have been listening hard through a different and simulating set of presentations. You've got some questions to ask or some comments to make.
Is there any way that the receding of glaciers can be reversed? Can the glaciers like come back or return or increase in size again?
Well, I suppose that will be entirely dependent on what temperature and precipitation does.
There's a lot of recreation activities in that part of the mountains, so it's like.
Yeah, no, I mean, and I'd say whether it's recreation or ecosystem function, I mean, the implications of the loss of snow and ice in the mountains is, they're pretty severe potentially. But I guess that's what all of the discussion globally in terms of greenhouse gas cuts are.
My first question is for Bill. You were showing us how precipitation has increased, like in the mountain areas, and it looked like in a large area of the rest of the province of BC, and there was a small area where precipitation had decreased. But then you said a little later on that for like major rivers in Alberta, there was like an increase coming from the glaciers in the mountains, which would make sense if they're receding, they're melting faster. But then you said that there was less volume of water coming from the watersheds. So when I put those two pieces of information together, it doesn't make sense, because if there's more precipitation in these areas, wouldn't there be more coming off the watersheds?
If you think about the map where I showed the temperature changes, in the northern half of the province, while there's been increases in precipitation, the substantial temperature increases ultimately result in more evaporative loss. If it rains on a hot day, the water on the ground doesn't stick around very, very much. I'd say that's one way of summarizing in a short term, but that's the importance to keep in mind in terms of future projections with temperature and precip change. It's the balance between precipitation and evaporative loss, essentially, that results in whether or not the supplies of water go up or down.
You know that there's a finite amount of water, fresh water, salt water, on the planet Earth. So I'm just trying to imagine, like, where is the water going? If it's not trapped in the glaciers, then it must be like downhill, like where we live, still here, but like where is it?
Yep, good question, and I'd say that's why, ultimately around the world, they're projecting different patterns of rain and water supply. In some places it'll be wetter, others it'll be drier, and I think we're in the unfortunate situation here in Alberta where we're in the rain shadow of the Rockies. I mean, not getting too much into it, but globally, if the atmospheric temperatures increase, the atmosphere itself has a greater capacity to hold water. It essentially, the water vapor, there's a substantial amount of water that's in the air that wouldn't have been before. But then also, again, it may dry out in Alberta, but it may get wet elsewhere in the world. So it's a matter of where you are and what the implications are.
Jan, thank you for being here. I have settler heritage, but the way that you speak of water and the respect that you just see inherently in that relationship to water is very, I just honor that. And so thank you for just having a voice for the water and having a voice for that sort of connection to the water, because I know my body's 70 to 80% water itself, so that's a pretty intimate relationship that I have with water. So just thank you. Thank you, all of you.
Yes, this has to do with retaining the amount of water that falls. Is there any attempt to retain the water that falls in the mountains, maybe through damming or whatever, and exploit it most advantageously or thereabouts?
Certainly there's a lot of discussion in terms of water in Alberta for either on-stream or off-stream storage, dams or reservoirs. And I'd say, going back to a lot of what Bill and Leon were talking about, I guess it depends sort of what we value most. Ultimately, one thing we do know is when you put dams in the mountains, it has significant effects downstream in terms of ecosystem function. You know, you have much lower spring and summer flows downstream, shallower waters, warmer water temperatures, less dilution of nutrients and point source pollution that comes in. So I guess that's going to be one of the questions that we deal with in terms of where we're going, sort of, you know, whether we prioritize human use and things like storage, to what extent we balance those with other needs and values.
When we look at the history of hydro dams and reservoirs in the eastern slopes, it's very short-term in nature, the way that these developments have come about. And we're not seeing that sort of long-term vision of how to manage water beyond just building reservoirs. Are we putting the value of homes in particular places above our overall need? Are we putting tourism and recreation needs above the water quality and quantity that we all need? And some of the panels that I've sat on before, we can't treat our headwaters like swimming pools. We need to reassess how they have been used, and we need to, again, have a long-term view of how water systems are going to be managed over a long term. The Spray Lakes, the Kananaskis Lakes, Bow River, North Sask, those are all impacted by dam developments, and consequently the Bow River Basin is closed to any new applications. North Saskatchewan Basin is, you know, is still open, but there's not much room for new applications for water usage. The Athabasca and the other regions I'm not sure about, but again, I would just say it's a result of short-term planning, the hydro and reservoir dams that have been created. I think that there's new ways of looking at landscapes, different ways of handling flood mitigation, different ways of protecting forests that ultimately feed into all the little tributaries that feed into river and water systems. But if we don't have that change in understanding, then we're going to continue to do the same things that we've always done. And that's why I think this NCE application through the Canadian Mountain Network is so important, is because it'll be adding a different way of doing research and understanding all of these water systems, vegetation, animal studies, everything that flows through the Canadian Mountain Network will be adding that alternate perspective around how we manage water, forests, mountains, and all these different areas. So it's timely that I think that the application is going forward.
For us, like in the Northwest Territory, when you talk about we can hold water, you know, we do have a lot of aquifer waters and stuff like that, you know, but it need to be studied, and, you know, you have a community-based data, then, you know, you can target those things, but none of that is available. So that's something to think about. And plus the other thing, like, you know, up north, Mackenzie River is getting wider too, so it takes up more water too. It spreads out more in the river itself. Yeah, but thank you.
I can't help but notice that all of our panelists tonight are men. And so I guess my question is this representative of your field? And if so, what are the barriers that you think are faced by women and people of color in ecology in Alberta?
I'm going to go with that one and say here at the University of Alberta, and also across various biological sciences departments in North America and also in Europe, the sex ratio is much more balanced than in some of the other sciences. Are there any chemists or physics people here? No? Okay. Biological sciences tend to have more of a balanced sex ratio at the department level, even up to the professorial. So that, yeah, That's a good observation here right now, but I can definitely attest to you that when we go to international conferences and society meetings like this, the representation of both men and women is actually quite comparable.
I held a workshop a couple of weeks ago on risks in relation to water in Alberta. That pattern in the attendees was also very apparent. I think the reality is that most of the senior people in many areas of our society, I won't speak for our Indigenous panel members and their communities, but the reality is old white guys are pretty dominant. But I know at our workshop, and that was certainly the case, we had a lot of sort of senior career academics, all of whom were old white guys. But then from our group, we also had a lot of the younger scientists we've hired, and the majority of them were women. So I'd say the panel here may not necessarily reflect where things are going, but I suppose you could pose that question to the organizers.
A colleague of mine who could have been here tonight, but unfortunately she was at a conference in Washington, D.C., so she couldn't make it. Otherwise, it would have been a little bit better balanced.
That was certainly one of the factors in the Network Center of Excellence application that was put forward from the Mountain Network, sort of an intentional decision-making in terms of inclusion and selection of leadership people in the network as more representative in terms of gender, as well as, I mean, of course, there's the substantial Indigenous community involvement. So that was one of the issues, I think, that the network was intentionally trying to help to rectify, at least at that network level.
Hi, this question is for the full panel. I'm just curious if you can speak to, building on what Mr. Snow was talking about just before the last question, how policymaking and trends have evolved over the last few decades, and how federal and provincial collaboration has evolved as well, if it has at all, related to conservation methods and either with forestry and logging techniques or water conservation.
The main evolution I would suggest is due to the increasing use of headwater ecosystems by people. So we've got an increasing population, and those people, many of them have desire and means to go and recreate in the foothills and in the mountains. And so I think the policy and regulatory changes that we've seen have largely been in response to that. In terms of what they are, forest management, I think, settled within Alberta into a model of harvesting and renewal several decades ago, and it's incrementally altered since then. A big driver in the eastern slopes is oil and gas development. And there's not many other ways to locate and produce oil and gas besides the ways that have been used for the last several decades. Seismic lines with underground charges to locate those reserves, the construction of roads to bring in the equipment and build the well, and then pipelines to transport it. The regulatory environment around that, I think, is mainly changed in the sense of what we call integrated land management, where the forestry and the energy industries now more than ever coordinate their activities so that we don't get, scenarios where two roads are built when one would have been enough. So those are a couple of the policy or I guess management strategies in the eastern slopes for at least those industries. In terms of conservation, I would say we're seeing an increase in protection within the eastern slopes. We've seen the increased protection in the Castle area, reduced human use in the Livingston Porcupine Hills, and now a proposal for increasing the protection of areas in the upper North Saskatchewan. So I don't know, that's all I'll offer, and maybe others can add.
I do have my 45-year pin from graduating from the Faculty of Science, just so you know. Most of my experience in the mountains, I was the Edmonton Journal writer and was syndicated through the Southern Network for 14 years. I've been to the headwaters of the Red Deer during winter, overnight camping and backpacking 21 times. I have a pretty good familiarity with the mountains, and the same with the whole North Saskatchewan. Now, one of the things we've heard through the discussion and the dialogue on from the press releases on the Bighorn backcountry, is that Edmonton's water supply is 1.5 million people are at risk because of the Bighorn backcountry. Whereas all of my experience, I see a great amount of the snowpack, whether it's the Dormer River and the McConnell Creek, all the places I've been, there's not, I don't see a problem where it comes out of the mountains in terms of, and I'm not an ATV user here, and I would like to know if there's been long-term studies on the North Saskatchewan, and again, I've been in the South Esk River, the whole Brazeau River, every single creek and river, and the headwaters, and I don't see the problem because most of them at that level, I don't see any risk. I drink the water out of every one of them, although I've had beaver fever a few times from mountain water. So I'm not sure if Dan can answer that question, or who might best know, or William Snow, but it's something that I've heard in the news a lot lately that I haven't asked any questions, but perhaps you can answer it.
The Bighorn Backcountry proper currently is designated as a public land use zone, which are 6 public land use zones, which restricts industrial activity and regulates human activity. The change that's being proposed is to something called wilderness parks, which affords potentially a little bit of additional protection, but I think your main point is spot on in that, in terms of water, the protection of water resources, that the altered land designation isn't going to make that much difference, if any, to the security of water supply for Edmonton, at least over the short term. You know, then you sort of read between the lines and read on in the news articles. There's other reasons for that alternative land designation.
I think it's a combination of the climate change impacts that we're seeing for the glaciers that feed into those all of those systems, but it's also the increase in all of the different types of industries. So all the projections for all of the population growth, the oil and gas activity, tourism, recreational activities that are going to, there's different planning tools now where we had one map here that showed a series of access roads. Now, if you think about it, each one of those access roads is leading somewhere, to a house or to a facility or a cultural center or main town site. So the increase in water usage associated with that it grows through all of those different developments. And so with some of these planning tools, you can now see, you can project what the water usage is going to be for a community or an area. These hydro and reservoir developments that have been put in place, that have been coming about in the 20th century, are not looking at that long-term view of 1.5 million today, 2 million in so many years, and all the associated developments with that. So I think it's in terms of planning, I think that's kind of where the scare is coming from. And just to go back to that one point about the policy development, the Alberta government today is undertaking a new way to look at policy. I've been involved with a group called the Traditional Knowledge Working Group, and we've been at work on developing a policy guide for the government of Alberta people in order to try to fit in traditional knowledge within their existing frameworks. Hopefully that guide will become available soon for the Government of Alberta ministries, but it'll be a public document, and so it'll be available to federal and provincial and other groups, municipalities that are looking at doing something similar. So there's not been a very good history of policy development with Indigenous communities previously, but hopefully this is a step forward in the right direction.
From a biological perspective, a lot of the larger scale environmental changes that we talked about this evening, they generally tend to be a relatively slow, gradual sort of process where they may be occurring, but you won't necessarily see them manifest a negative impact on water quality. But in some cases, it's not a gradual decline. In many cases, once these regional changes have been in place long enough, you often cross kind of like what's termed kind of like a biological threshold, where once they reach some certain point of disturbance, the water quality can shift very dramatically, but for quite a long period of time, it's a very kind of cumulative process where you kind of go, well, we're doing all these things, but the water doesn't really seem to be deteriorating in quality, and all of a sudden then you hit a particular type of biological threshold, and then the change can be very rapid.
I'm trying to put all of this together. You've each brought a different perspective from where you work and where you live. What's your individual, or is it a collective call to action? What do you want us to take away and do with the knowledge that you've shared with us? William and Leon, you each have a unique association with water that the rest of us have a negative impact on in what we do, but you also get to speak and help protect that. You're nestled between you are three scientists who obviously can create knowledge to educate the world and hopefully create social actions. I guess I want to know, is this an individual call to action from each of you, or do you each have is it a collective? What do you want us to do about this, or with the knowledge you've given us tonight?
For me, what's important is to take away from this is we talk about water quantity. If the water quantity is not there down Mackenzie River, the quality won't be the same. So for me, this is just something to be aware of, passing on awareness in people so they know what's important for us up in Mackenzie River. So that's very important for me. You know, the quantity is not there, then the quality won't be there either.
I'm going to phone the gentleman who asked the question about get him to show me some of the areas that he's cross-country skied in the upper headwaters of the Red Deer River. So, but seriously, these are beautiful areas, and they're places worth visiting and spending some time in. So that'd be one of my takeaways, is to encourage people to get out there.
One of the things that first attracted me to doing work in the mountains is that I kind of considered, you know, I like places that still have some sort of essence of wilderness or being wild. And the longer I've actually been researching the mountains, the more and more I started realizing that that's somewhat of an illusion, because if you dig deep enough, you'll actually see that this, you know, relatively pristine landscape is not one that just because it's been there for a long time can be assumed to kind of continue on into the future, and that I think personally we're kind of like nearing some sort of like threshold where it's going to be some very, very fundamental changes that manifest themselves around water quantity and water quality supply to humans. And I really think that, again, just kind of somewhat similar to like the whole global warming climate change event, it's something that I think is going to be accelerating a lot more quickly than we might imagine or appreciate at this point. And so I think this is where some sort of collective effort that goes across multiple disciplines is actually quite important.
I would hope that perhaps people's interest has been piqued a little bit. Hopefully they will have learned something, and then where appropriate, pursue further avenues of information. There's all kinds of issues here that, whether it's, you know, mountains as recreational areas for its cultural and social values. There's dynamics at play in terms of, you know, federal and provincial politics. There's treaty and constitutional rights. There's all kinds of things at play. It's very dynamic, both, I'd say, from a management and decision-making perspective, as well as ecologically and scientifically. I would think, and I don't know if Roger or maybe Christy are going to talk about the Mountain Network and its mandate. I think it captures a lot of those, and I would say as people go through the mountain parks or into the foothills, hopefully some of you will think of things beyond just the vistas that you see or the recreational activities. I think we need to think of these as dynamic living systems and then start considering the values that they provide to us and how we manage them.
Yeah, I think it'd be important to understand water not just from the view of Western science. We've been too reliant as a society on basing all of our decisions on the Western science and technology that's going to solve all our answers. I think what we need to do is basically what we're doing with this Canadian Mountain Network is we are adding to our perspective using a separate type of knowledge system, traditional knowledge, to add to the research process. The things that may not make sense in Western science may have an answer in traditional knowledge. And so that, if we can broaden our understanding of place, will add to what we know.
Well, thank you everyone for staying a bit late here. Wonderful questions, I think amazing talk. So thank you to our panelists, and Roger, thank you very much for the facilitation. It was really great. So I hope we can all just give a final round of applause for everyone today. Thank you.